Good morning, my dear students. Today I will continue the problem number 36. If the function f of x is equal to 1 minus cos x divided by x square for x not equal to 0, k for x is equal to 0 is continuous at x equal to 0, then what is the value of k? Okay. So he is asking at x equal to 0. At x is equal to 0, f of 0 is equal to k given. It is already continuous. So we have to find limit of a function. Limit of f of x as x approaches to 0. Okay. So what is the f of x value? Limit 1 minus cos x divided by x square as x approaches to 0. Now we have to use any method, either traditional method or shortcut method. Okay, in CET exam, maximum we should apply shortcuts. Observing, apply the limit here. 1 minus cos 0 is 1. 1 minus 1 is 0. Divided by 0 square. So this is called IDF form, indeterminate form. If you get indeterminate form, what is the method? So we have to apply LHS rule. LHS rule apply. Using LHS rule, so this is equal to limit x tends to 0. What is the LHS rule? Differentiating numerator and denominator separately. One differentiation 0 minus cos x differentiation minus sin x, minus into minus plus sin x divided by x square derivative is 2x. Now you apply the limit. If you apply the limit, sin 0, 0 divided by 0. Again we are getting indeterminate form. Indeterminate form this is also. So this is equal to, again I have to use LHS rule. Second time, limit x tends to 0, differentiation of sin x cos x divided by 2x derivative is 2. Apply the limit, we get cos 0 is 1, 1 divided by 2. I got limit of f of x is equal to 1 by 2. Since f is continuous, since f is continuous at x equal to 0, this means limit of a function is equal to f of 0. What is the limit of a function? 1 by 2. 1 by 2 is equal to k. So now what is the k value? This will be 1 divided by 2. So this is the answer. So option number 3 right answer. So last class we have done many problems this model. So procedure is same. If you are getting 0 by 0 form, we have to use LHS rule. Very easy to solve the question. Okay? It is one of the shortcut method. Remember once again, LHS rule means differentiate numerator and denominator separately. We have to use this rule until the getting finite value. Here first time we did not get the finite number here. Again apply the last order rule. Next question. Next problem. Read the question. The function f of x is equal to log of, look at the function given, log of 1 plus ax minus log of 1 minus bx divided by x, not defined at x equal to 0, means x not equal to 0. The value which should be assigned to f at x equal to 0 so that f is continuous. What does it mean? It means we have to find f of 0. Since what is the given? F is continuous at x is equal to 0. So now we have to find f of 0. That is limit of f of x. Limit of f of x as x approaches to 0. This is equal to limit of, what is the f of x? Log of 1 plus x minus log of 1 minus x divided by x as x approaches to 0. Okay, limit of log of 1 plus x minus log of 1 minus ax 1 minus bx divided by x. Okay, we have to find f of 0 value. You observe that apply the limit first. Log of 1 plus 0, that is log 1. Log 1 is 0. Minus log of 1 minus 0, that is log 1, also 0. 0 minus 0, 0, divided by 0. So what do you call this is? Indeterminate form, IDF, shortly write. If it is an indeterminate form, what we will do? So what to do? We have to apply shortcut method. What is the shortcut method? Differentiating, L'Hospital rule. Differentiating numerator and denominator separately. So I will differentiate here. This is equal to limit as x approaches to 0. Now apply the differentiation. As we know, log x derivative. Log x derivative is equal to 1 divided by x. So function of a function this is. Log x derivative 1 divided by 1 plus ax into derivative of 1 plus ax is a minus log of 1 minus bx derivative 1 divided by 1 minus bx into derivative of 1 minus bx is minus b. Now you apply the limit. This is equal to a divided by 1 plus 0 minus into minus plus b divided by 1 minus 0. So we get a plus b. So f of 0 is equal to a plus b is the answer. F of x 0 is equal to what? A plus b. So is there an option? Yes, the fourth one is the right answer. How much easy observing? So this is the main method in the continuity only. Continuous, already it is a continuous. We have to find f of 0 according to question. Clear? L'Hospital rule, very easy now. If you are getting IDF form, we have to use L'Hospital rule until I getting finite value. We can easily find out any type of question. Maximum questions we are getting here. That is the shortcut here. Next problem. See the problem number 38. The function f of x is equal to mod of x minus 2 plus x is, four options are given: differentiable at x equal to 2 but not at x equal to 0, differentiable at both x equal to 2 and not equal to 0, continuous at both x equal to 2 and not x equal to 0, continuous at x equal to 2 but not at x equal to 0. Okay, so here first of all mod x function is there, we have to find the function here. So what is the f of x value? Mod of x minus 2 plus x. We have to find when x is smaller than 2. If x is smaller than 2, so f of x value, what I will find? F of x value minus of x minus 2 plus x. Here there is no change. Only in this mod property only change. When x is smaller than 2, mod of x minus 2 equal to minus of x minus 2. So here minus x plus x cancel, minus and minus, this is equal to 2. When x is less than 2, this is the function. Similarly, when x is more than or equal to 2, what is the f of x value of the code? More than 2 means what? X minus 2 positive number plus x. This is equal to, it becomes here 2x minus 2. So we got function here. So what is the function here? F of x is equal to, therefore f of x is equal to 2 when x is less than 2, 2x minus 2 when x is more than or equal to 2. So this is the original function while you are breaking into conditions. Whenever you are breaking into conditions, we got f of x value when x is less than 2 is 2, when x is more than or equal to 2, 2x minus 2. Now we have to check whether it is a continuous or not at x is equal to 2. So firstly, f of 2 find out. At x is equal to 2, f of 2. So this is the equality condition. So f of 2 is equal to 2 into 2 minus 2. This equals 4 minus 2 is equal to 2. Okay, so we got f of 2 is equal to 2. Then left hand limit breaking conditions are given. What is the left hand limit? LHL. Limit of f of x as x approaches to 2 minus 2 negative, that is. So left hand limit smaller than 2. I would have write this number limit of f of 2 minus h as h approaches to 0. Okay, both are giving same meaning. 2 minus h meaning smaller than 2. When x is smaller than 2, f of x value is 2. So this is equal to limit of 2 as h tends to 0. This is equal to also 2. I got left hand limit is equal to 2. In the same manner, I have to find right hand limit or HL. Limit of f of x as x approaches to 2 plus. 2 plus meaning from right hand side of 2. That is more than 2. Okay, for sake of understanding, I would have write limit of f of 2 plus h here limit of 2 bracket x value is 2 plus h minus 2 as h tends to 0. Okay, now you apply the limit. If you apply the limit, we are getting 2 into 2 plus 0. So this is equal to 4 minus 2, that is equal to 2. You observe what? F of 2 is equal to 2. Left hand limit is equal to 2. Right hand limit is equal to 2. So therefore, LHL is equal to RHL is equal to F of 2. This meaning F is continuous at x is equal to 2. F is continuous and x is equal to 2. So F is continuous and x equal to how many options are there available? So it is continuous, this may be third or fourth will be there. So differentiable also may be satisfied. May or may not. But every differentiable function is continuous. But every continuous may or may not be differentiable. Okay, next where we have to check and x is equal to 0. Next one is and x is equal to 0. And x is equal to 0 means it is always smaller than 2 also. So smaller than 2, what is the value? Only 2 is there. Function is 2, limit of the function also 2 there. So at x equal to 0, f of 0 will be 2 and limit of f of x as x tends to 0 also is 2. Therefore, f is continuous at x is equal to 0 also. So it is continuous at both x equal to 0 and x is equal to 2. So answer will be third option. Okay, it is continuous at x equal to 0. Why? Because only constant. We know that every constant function is continuous everywhere. Every identity function is continuous everywhere. So this is the problem number 38. So we have to check differentiability. Limit of left hand derivative, right hand limit derivative. Check out that is. What is the left hand derivative? Limit of f of a plus h minus f of a divided by minus right hand limit, that is plus h. Left hand limit of f of a minus h minus f of a divided by minus h. Find out that value if it is differentiable or not. So we are going to maximum continuity chapter. So that is continuous and both x equal to 2 and x equal to 0. Next problem. Okay, problem number 38. 39 this is. Next question is 39. See the problem. F of the function f of x is the function f of x is greatest integer of x, where greatest integer of greatest integer not greater than x is. Last class I defined these things. Very important question model. This is also greatest integer function. Once again I will explain. You take an integer and non-integer. So remember this question without doing also. At integer, step of x function is always discontinuous. Number of points of discontinuity undefined. Infinity. Next, at non-integer, the greatest function is always continuous. Number of points of discontinuity is undefined. Okay, for sake of understanding this problem, let x is equal to a belongs to integer I am taking. Okay, at integer only. So now we have to find is equal to also A. For sake of understanding, you take A is equal to any number 2. Okay, A is equal to 2. If I take, this is understanding method only. 2 means a number. Greatest integer of 2 is equal to 2. Integer only we have to check it here. Next, left hand limit we have to find limit of f of x as x approaches to a negative. So remember to negative, keep in our mind on that is. This is equal to limit of f of a minus h as h tends to 0. This is what? Smaller than a. This means smaller than 2. When x is smaller than 2, that is. So now function, greatest integer function, substitute that limit of greatest integer of a minus h as h tends to 0. It is a number only, number. If I take 2 number, 2 minus h. H is the very small quantity. Greatest integer of 2 minus something is 1 point something. Greatest integer of 1 point something is 1 only always. So this is equal to 1. This 1 is what actually 2 minus 1. Okay, 2 minus 1. So that means greatest integer of a minus h is equal to a minus 1. Greatest integer of a minus h is equal to a minus 1. I hope that you understand this point. Clear? Shall we go next right hand limit? What is the R in h here? Limit of f of x as x approaches to a positive. This is equal to limit of f of a plus h as h approaches to 0. That is 2 plus h, more than 2 meaning. So now this is limit of greatest integer of a plus h as h tends to 0. Observing all of you, 2 plus h, more than 2, that is 2 point something only. It lies between 2 and 3. What is the greatest integer of 2 point something? It will be 2 always. So here 2 means what? A. 2 is equal to a. Now we got left hand limit is equal to a minus 1. Right hand limit is equal to a. F of a is equal to a. So these are equal. Aren't they equal? No, these are not equal. So therefore left hand limit is not equal to right hand limit. This is equal to f of a only. Therefore what do you say? F is discontinuous. F is discontinuous at x is equal to integer. So at all integers, the function is discontinuous. At non-integers, so remember your note, if you take any non-integer, that is continuous. At non-integers, f of x is equal to greatest integer of x is continuous. This is continuous at non-integers only. So you go like this. You take any 1 point of last class. I explained this model problems. Same model question is there. I explained second time also. So you should do that. So the answer is, after that, continuous only positive integral value of x. It is wrong. In all integral values of x. Continuous for all non-integral values of x. So it is the correct answer. Continuous only rational values, no. Continuous from all real values, no. So it is continuous only non-integral values. It is discontinuous at integer values. Discontinuous at integer See the next question. If f of x is equal to log x divided by x minus 1, when x not equal to 1, k when x is equal to 1 is continuous at x equal to 1, then what is the value of k? So you are taking, since f is continuous at x is equal to 1, this is the given condition. This meaning f of 1 is equal to limit of f of x as x approaches to 1. f of 1 is already given. f of 1 is equal to what? K. K is equal to limit of, what is the function? Log of x divided by x minus 1 as x approaches to 1. Now you apply the limit. Log 1 is 0 upon 1 minus 1, 0. So this is 0 by 0. If there is ideal form, what we will do? We have to do it differentiation in both numerator and denominator, which is called L-Hospital rule. So using L-Hospital rule, k is equal to limit of log x differentiation 1 divided by x divided by x minus 1 divided by 1 as x approaches to 1. Now you apply the limit. Limit of 1 divided by 1 is equal to, apply 1 by 1, that is equal to 1. Therefore k is equal to 1. So option number 3. Third option is the right answer. Simple question. Already asked. This type of was asked 2 to 3 times in exam. Repeated questions are very nice. Next question. See the next problem. f of x is equal to x square minus of a plus 2 into x plus a. If x is not equal to 2 if x is equal to 2. But here one more, that is x minus 2 there. Okay, this is the problem. Divided by x minus 2, missing number again. See this question answer how to solve. So what is the condition here? Already it is a continuous. Since f is continuous at x is equal to 2, it means f of a is f of 2 is equal to limit of f of x as x approaches to 2. This implies f of 2 is 2 given. This is equal to limit of f of x, that is what, x square minus of a plus 2 bracket x, a plus 2 bracket goes x plus a divided by x minus 2 as x approaches to 2. Now you apply the limit directly. This implies 2 is equal to 2 square 4 minus of a plus 2 into 2 plus a divided by 2 minus 2 is 0. Now we want to find out a value. So cross multiply. This is equal to 0, 0 into 2, 0 is equal to 4 minus. So here multiply minus 2a minus 4 plus a. Okay, 4 any L'Hospital rule, directly we can apply this. It is already continuous means f of a is equal to limit of f of x as x approaches to a. Okay, you can use this rule, very easy to solve. So limits, most of this is related to limits chapter. Differentiation also like this. Next problem. Next question is let f of x is equal to x if x is rational. 0 if x is irrational. 0 if x is rational, then f is. I have given one shortcut also. Generally, it is okay. It has so many points are there at any point. At x equal to 0 means here, whatever there we should. I have given one shortcut. These two numbers are equating, solving these two values. So we get only x is equal to 0. Okay, it means what? Where it is continuous? It is continuous only at x equal to 0. Everywhere it is not a continuous. So remaining at all points, it is a discontinuous. So observing the shortcut is very simple, solving only these two values. So it is continuous everywhere, it is wrong. Discontinuous also everywhere, it is wrong. Continuous only at x equal to 0. Yes, it is only continuous at x equal to 0. Except 0, it is a discontinuous. But continuous at all rational numbers, it is not right. So answer will be third. So already last class 2 to 3 questions we completed this model. X 1 minus x problem. X 1 minus x given, say 1 minus x solving. X is equal to 1 minus x. So 2x is equal to 1, x is equal to 1 by 2. So very simple shortcut is there. So it is continuous at x equal to 1 by 2. And remaining at all points it is discontinuous. Because every number, if we take any number, that should be infinite number of rational numbers and irrational numbers. Okay, this is the answer. Simple model, very easy to solve. Using graphical method also we can do it. Next problem. This is all of the previous questions. The function represented by the following graph is only given. Continuous but not differentiable at x equal to 1. Differentiable but not continuous at x equal to 1. Continuous and differentiable at x equal to 1. Neither continuous nor differentiable at x equal to 1. Is it a continuous graph? See here, graph is very clearly given. This is V shape. This is what you call. So the function is f of x is equal to mod of x minus 1. Correct? So this graph is mod of x minus 1. So what is this graph? So remember, y is equal to mod x minus 1. So left side. If you move left side of y, this is y is equal to mod of x plus 1. If you move right side of a, x minus 1. So x is equal to 1 point. So mod x function, we know that it is continuous for all real numbers. Mod x function is continuous. So we can say it is continuous. How many options are satisfied? Either first one or second one, third one. Maybe either first one or third one only. And one more thing, differentiable also. So anyway, we have to show like this. So I have to make the function minus of x minus 1 and x is less than 0. X minus 1 and x is more than or equal to 0. This is the mod of x minus 1. Firstly, we have to calculate continuity. Continuity meaning left hand limit, right hand limit, we know very well. Okay, once again I will have check at x is equal to 1, this is of 1 value observed. F of 1. So x is equal to 1. This is 1 minus 1. That is equal to 0. Now right hand limit also find out. Left hand limit also find out. Directly we can say that it is continuous. Okay? Left hand limit. Limit of f of x as x tends to 1 minus. This is equal to limit of f of 1 minus h as h tends to 0. This is equal to limit of when x is smaller than 1, f of x value minus of x minus 1. That is minus of x value 1 minus h minus 1. Okay? As h tends to 0. So plus 1 minus 1 cancel, minus of minus plus h apply the limit, it is equal to 0. So I got left hand limit is equal to 0. Similarly right hand limit also. Right hand limit or h limit of f of x as x approaches to 1 plus. This is equal to limit of f of 1 plus h as h tends to 0. This is equal to limit of 1 plus h more than 1. When x is more than 1, f of x value x minus 1. 1 plus h minus 1 as h tends to 0. So plus 1 minus 1 cancel and this is equal to apply the limit 0. So observe what here, left hand limit is equal to right hand limit is equal to f of 1. So f is continuous. Therefore LHL is equal to RHL, that is equal to f of 0, f of 1. Hence f is continuous and x is equal to 0. But every continuous function may or may not be differential. Okay, one question I will show that how to prove the differential. So continuous, understand? Okay, now I will show the differentiable function. So shall I remove this one? Okay, function I am taking differentiable. So left hand derivative, right hand derivative, how to find out? Left hand derivative. So it is already continuous in order. Now we have to see the left hand derivative. So to show that differentiable functions, you apply this method. Very easy. First principle rule it is called. That is the limit of f of a minus h. That is a value is 1. 1 minus h minus f of 1 divided by minus h as h tends to 0. Directly converted to beta. First principle f of a minus h minus f of a divided by minus h. Remember, when there is a minus h, here also minus h will come. Shorting. Don't forget this is left hand derivative. Now you apply the function. Limit h tends to 0. 1 minus h. Left hand derivative, this is no less than 1. 1 minus h meaning less than 1. So that is minus of 1 minus h minus 1 minus f of 1. What is the f of 1 value? Already it is 0. Divided by minus h. Okay. Now apply this plus 1 minus 1 cancel. So after that minus of minus plus h. Plus h by minus h cancel only. Minus 1. Limit of minus 1 is equal to minus 1. So I got left hand derivative is equal to minus 1. In the same manner right hand derivative also find out. Or h. limit of f of a plus h, 1 plus h minus f of 1 divided by h as h tends to 0. So this is left hand derivative, minus h there, minus h, plus h, denominator plus h. First principle concept. Now apply the limit. This is equal to limit of f of 1 plus h more than 1. When x is more than 1, x minus 1 is there. Substitute 1 plus h minus 1 minus of f of 1 is 0 divided by h as h tends to 0. So plus 1 minus 1 cancel. Only h by h, that is equal to 1, limit of 1 is equal to 1. So you observe what? Left hand derivative not equal to right hand derivative. Therefore LHD does not equal to RHD. If left hand derivative not equal to right hand derivative, it is not a differentiable at x equal to 1. So it is a continuous but not differentiable at x equal to 1. So what is the answer of this one? Continuous but not differentiable at x equal to 1. So option number 1. So with the graph also, without, we can say it is a continuous graph. Discontinuous graph, we can say that. Differentiability model, you do it like this. Left hand derivative, right hand derivative, apply it. So I will give here left hand derivative formula. Limit of f of a plus h minus f of a divided by, left hand is a minus h divided by minus h as h tends to 0. H is the very small quantity. Right hand derivative, how to check out? Limit of f of a plus h minus f of a divided by plus h as h tends to 0. So use these two formulas, we can find out whether it is a differentiable or not a differentiable function. Clear? So you do it like the questions, very easy to solve. Continuity as well as differentiable, compulsory questions are there. Most of the field, the people are difficult in this chapter. So how to they have no patience. If you have patience in it, with patience only we can do it all questions next. Sufficient time will be there. Next question 44 I am going here. Problem number 44. What is the 44 problem? If f of x is equal to 3 sin of pi x divided by 5x when x not equal to 0, 2k when x is equal to 0. Is a continuous at x equal to 0, then the value of k is. Already it is a continuous problem. Since f is continuous, at x is equal to 0. So this means f of 0 is equal to limit of f of x as x approaches to 0. Okay. So f of 0 is equal to 2k. 2k is equal to limit of f of x value 3 sin of pi x divided by 5x. Okay, this is equal to, this implies 2k is equal to 3 divided by 5 outside constant. And remaining what? Sin of nx by x formula. Limit of sin nx by x as x tends to 0 equal to n. What is the n value? 5. 3 pi by 5. K is equal to what? 3 pi divided by 10. This is the answer. Nothing here, just a formula only. limit of sin nx by x as x approaches to 0 is equal to n. Coefficient whatever there, that will come here. Sin x by x formula. Limit of sin x by x is equal to 1. Limit of sin nx by x as x tends to 0 equal to n. So use that formula. Next question. F of x is equal to, see the next problem. F of x is equal to 3x minus 8 when x is less than or equal to 5. 2k when x is more than 5 is continuous at x equal to 5. Then what is the value of k? Almost of same model. Since f is continuous at x is equal to 5. That means what? F of 5 is equal to limit of, but here something is given here. Left hand limit is equal to given, right hand limit is given, okay? So we do left hand limit, right hand limit firstly. Okay, f is continuous, noted. So breaking conditions are given. Finally we can equate them. So firstly at x is equal to 5, f of 5 is equal to 5. When x is less than or equal to 5, x is equal to 5, f of x is 3x minus 8. So 3 into 5 minus 8, 15 minus 8 is equal to 7. Then left hand limit of f of x as x approaches to 5 minus, this is equal to limit of f of 5 minus h as h tends to 0. Left hand limit less than 5. When x is smaller than 5, this is only function. This is equal to limit of 3 into 5 minus h minus 8 as h tends to 0. Apply the limit. This is equal to 3 bracket 5 minus 0 minus 8. 15 minus 8 is equal to 7. I got left hand limit is equal to 7. In the same way, right hand limit calculate RHL. Limit of f of x as x approaches to 5 plus more than 5. This is equal to limit of f of 5 plus h as h tends to 0. This equals limit of, say here, when x is more than 5, f of x value is 2k. 2k as h tends to 0. So this is equal to 2 times of k. Since f is continuous, since f is continuous at x is equal to 5, it means what? Left hand limit is equal to, that is LHL is equal to RHL is equal to f of 5. How much we got? Left hand limit 7, right hand limit 2k, f of 5 also 7. So therefore 7 is equal to 2k, k is equal to what? 7 divided by 2. K is equal to 7 divided by 2. So do we have answer? 2 by 7, 7 by 2, last option. So it is the continuity model. Find the left hand limit, right hand limit. If it is continuous, equating. All are equal means. So equating any two terms, I equated 7 is equal to 2k, k is equal to 7 divided by 2. First term 7 divided by 2. Next problem. See the next problem, that is 46 problem, 46, same model problems. Some more questions are there. Previous questions I will explain to you. The question is, continue problem I take here, 46 problem. If f of x is equal to kx square when x is smaller than or equal to 2, 3 when x is more than 2, is continuous at x is equal to 2, then the value of k. What is the value of k? 4 options are given. 3 divided by 4, 4 divided by 3, fourth option is 3 by 3 is given. So what is the value of k? So you can easily solve this type of questions. In CET, this the k value find out right. So in theory also k values are very important. I have given 26 to 30 problems are very important in theory. NCERT textbook problems. So here already is continuous. Okay. So here breaking conditions given, we have to find left hand limit, right hand limit values. So here at x is equal to 2, what is the f of 2 value? X is equal to 2, condition is there. So f of 2 is equal to k into 2 whole square. This equals 4 times of k. Now we have to find left hand limit, LH here. That is limit of f of x as x approaches to 2 negative. I have to change this value easily. Limit of f of 2 minus h as h tends to 0. So limit of what is the x here? X is equal to smaller than 2. When x is smaller than 2, f of x is kx square. So k into x value is 2 minus h whole square as h tends to 0. Now you apply the limit. This is equal to k bracket 2 minus 0 whole square becomes 4k. So this is the left hand limit value. And also we have to calculate right hand limit. So we have to find right hand limit or h here. Limit of f of x as x approaches to 2 positive. This equals limit of, I converted more than 2 means how to write f of 2 plus h as h tends to 0. If x is more than 2, what is the f of x value? 3. So this equals limit of 3 as h approaches to 0. Limit of a constant is equal to 3. Since f is what? It is a continuous. Since f is continuous at x is equal to 2. What is the meaning of this? That is left hand limit is equal to right hand limit is equal to f of 2. How much we got left hand limit? 4k. Right hand limit is 3. F of 2 also 4k. Now equating any two terms, what is the k value? 3 divided by 4. K is equal to 3 divided by 4 is the answer. So we have to do it So simply equate this one. 4k is equal to 3. Already it is continuous means this much concept is known in the exam, CET exam. So n x equal to 2 becomes what? 4k. It is already continuous. 4k is equal to 3. So k is equal to what? 3 by 4. Clear? Like you should do it your own methods. Next question I am taking. So take another this one. I don't know you answer this is. I will take the 47th problem. The value of f of 0. The value of f of 0 so that f of x is equal to square root of 1 plus x minus 1 divided by x is continuous at x equal to 0 is. So he is asking directly f of 0 asking. It is already continuous. We know all of it. If f is continuous, then limit of f of x equal to f of a definition. So using definition only we can write. So already it is what? Continuous. Since f is continuous. F is continuous at x equal to 0. What? That is what? F of 0 is equal to limit of f of x as x approaches to 0. What is the f of x value? Substitute here limit of square root of 1 plus x minus 1 divided by x as x approaches to 0. Now you apply the limit. If you apply the limit, what happens? Observe that square root of 1 plus 0 is 1. 1 minus 1 is 0 divided by 0. I get indeterminate IDF form. If it is an indeterminate form, how to solve this question? Square root problems are there in generally traditional method, rationalization method applying. But in CET classes, what to do? Use L'Hospital rule. So using L'Hospital rule, what is the L'Hospital rule? Differentiating numerator and denominator separately. How does it appear? It looks like root x. Root x is the differentiation 1 by 2 root x. 1 divided by 2 root of 1 plus x. Derivative of 1 plus x is 1 minus derivative of 1 is 0 divided by differentiation of x is 1. Now you apply the limit. This is equal to 1 upon 2 into square root of 1 plus 0 is equal to 1 divided by 2. So your 4 options are there. So option number 1 is 1, option number 2 is 2, option number 3 1 by 2, option number 4 3 given. So what is the answer? Third option is the right answer. So using rationalization or using L'Hospital. So here we apply L'Hospital. This is the very shortcut method to solve the limits problems. To remember all of you L'Hospital rules. What is the L'Hospital rule? Differentiating numerator and denominator separately. Are you okay? Next question 48. Another 2 to 3 questions I will give here. Right on. Problem number 48. 48 problem is if f of x is equal to x raised to 5 minus 32 divided by x minus 2 for x not is equal to 2 is continuous and x is equal to 0 is okay, x equal to 0 is continuous at x equal to 2 and x is equal to 2, then f of 2 is, what is the f of 2 value? Same, almost it is similar question, exactly similar. Options also given. First option is 16, second option is 80, option number 3 32, option number 4 80. Okay, it is already continuous and x equal to 2. So according to problem, since f is continuous and x is equal to 2. So this meaning f of 2 is equal to limit of f of x as x approaches to 2. We have to calculate f of 2 value, evaluate f of 2 using problem condition. Limit function. So this equals limit of, what is the f of x? X raised to 5 minus 32 divided by x minus 2 as x approaches to 2. So we have done this question in theory also, first year. Using formula or else L'Hospital rule. So apply here, this is, it becomes 0 by 0 form, indeterminate form. So use L'Hospital rule, you can get answer limit x raised to 5 derivative 5 into x raised to 4 minus 0 divided by 1 minus 0 as x approaches to 2. So this is L'Hospital rule. Okay, using L'Hospital rule, we do this. Now apply the limit. This is equal to 5 into 2 raised to 4, that is 5 into 16, that is how much? 80 is the answer. So there, yes, second option is there. My point of view, continuity by practicing, it is very easy. After that, any question is given in exam, you can solve that. First, beginning only, mainly, it is taking trouble. What is how to change the limits? That is left hand limit, right hand limit. That logic, if you understand, left hand limit out right, a minus h, subtract h value from the limit given value. Right hand limit what? Adding plus h, f of a plus h. That only change. Remind everything is easy. So don't confuse. I avoided confusion also. You should practice. Okay, one more question shall we do? Same order problems 49. Take down problem number 49. If f of x is equal to, take the question, square root of 1 plus kx minus square root of 1 minus kx divided by x. Second one, 2x square plus 3x minus 2. So this condition, minus 1 less than or equal to x less than 0. 0 less than or equal to x less than or equal to 1. Okay, 2x continuous at x equal to 0, then k is equal to, then k value is what? Options, first option is -4, second option -3, third option is -2, fourth one is -1. So this is the question. F of x is equal to square root of 1 plus kx minus square root of 1 minus kx when x is smaller than 0 and more than 0. This is given. Inequality condition. Breaking conditions are given. So we have to find out left hand limit, right hand limit, then we can find the k value. Okay, when x is equal to 0, this is the function only. So we have to check out at continuous at x equal to 0. So at x is equal to 0, we have to see first f of 0. So when x equal to 0, what is the f of x value? 2x square plus 3x minus 2. That is 2 into 0 square plus 3 into 0 minus 2. This is equal to minus 2. Okay, next one. Left hand limit we have to find next one. LH here. That is limit of f of x as x approaches to 0 minus. This is equal to limit of f of x value when x is smaller than 0. So directly shall we take this one? Okay, as x approaches to 0 minus square root of 1 plus kx minus square root of 1 minus kx divided by x. Just you see that is no need the total values to be found. When x is smaller than 0, this is a function only. Okay, it means x equal to 0. If x equal to 0, what happens? 0 by 0 form. Indeterminate form is getting IDF. If you are getting IDF, what we will do? Apply the Laws formula. So this is equal to limit x tends to 0 minus differentiation find out root x divided 1 by 2 root x 2 into square root of 1 plus kx into 1 plus kx derivative is k minus 1 divided by 2 into square root of 1 minus kx into derivative of 1 minus kx value minus k divided by derivative of x is 1. Now you apply the limit x equal to 0 meaning directly do it. Don't waste your time. Always going to come out. So this is equal to apply the limit. We are getting k divided by 2 into square root of 1 plus 0. That is k divided by 2 minus into minus plus k divided by 2 into square root of 1 minus 2. K divided by 2 plus k divided by 2 is equal to k. Similarly, right hand limit also. Right hand limit or h here. Limit of f of x as x approaches to 0 plus. This is equal to limit of what is the f of x when more than 0? 2x square plus 3x minus 2 as x approaches to 0 plus. I will apply directly limit. So 0 plus 0 minus 2, that is equal to minus 2. Okay. So now since f is 1, it is continuous. Since f is continuous at x equal to 2. This means left hand limit is equal to right hand limit equal to, that is left hand limit how much there? K is equal to minus 2. So this is the answer. So maximum time make it reduce. Okay, we should reduce the risk. Directly do that. We can easily find out using a loss for load concept. Note on this problem. So like this, different questions are asking in exam. So all type of questions we should cover here. Okay, one more question. I'll give that right on 50th problem. Take on this problem. So what is our problem number 50? Last question. Next remaining is do it. 50th problem. The discontinuous functions. The discontinuous functions. Discontinuous points of f of x is equal to 1 divided by log of mod x, or so options are given. First option is 0, plus or minus 2. Second option 1, plus or minus 2. Third one 0, plus or minus 1. Fourth one 0, plus or minus 3. Okay. So where it is discontinuous. So where it is not defined enough. So log x function is not defined at x equal to 0 also. Okay. So this function, observe that all of you, f of x is equal to 1 divided by log of mod x. Suppose this whole function is 0, is it defined here? No. So it is not defined means x equal to 0, it is not defined. When x equal to 0, it is not defined. When whole function is also equal to 0, not defined. If I take 1, log 1 is 0, so that is 1 upon 0, that is not defined. So what are the x values? Either 0 or plus 1 or minus 1. Mod of x, okay, plus or minus 1. So it is number of points of discontinuity is equal to 3. So it is not defined at x equal to 0, at x equal to plus 1, at x equal to minus 1. In all these values, the function is discontinuous. Okay. So like we have to solve number of questions. Refer the different textbooks. You can solve that how to find the continuity, discontinuity models. Okay, different functions only. So model is same, only one model here. We have where it is continuous, where it is not continuous. Practice like all the questions, you can get perfection. Are you okay? Thank you.